Okay, so in this example today, what we will see is some Forex exchange uh, values and see how they evolve over time and which are their relationships. So for instance, we have taken these pairs, so we have euro dollar, euro Swiss franc, euro Japanese yen, and USD dollar Swiss franc, USD Japanese. And for each one, this is data from 2000, and then for each one of these we have them in blocks of 15 minutes, and within these blocks we have what was the highest exchange rate, the lowest, the open and close. So for instance, here in the euro dollar we see that this is euro divided by dollar, so it was 1.008, the highest value, the lowest 1.0073, and then this was the open of the period, this was the close of the period. So within this period we see that it started at this value that was the lowest value, then it went up to 008, and then it came down to 0077, and so on for different periods. So we have 50,000 of these entries, and then we see that all of them are floating numbers, and then we will work simply with the close values, so just this column. Okay, so we observe that we have 4 different currencies. So we have euro, dollar, Swiss franc, and Japanese yen. We have 5 pairs, but only 4 independent sources of information. So let's see if we can capture that with PCA. Okay, so let us explore the data as always. So we see what is the minimum, what is the maximum, and we see that the most variable ones are the euro, yen, and the dollar yen. And the reason is that the yen has very high values. You see this, while euro and Swiss franc and US dollar are all in the ratio around 1. The Japanese is in the ratio about 100. So that is why we have a larger standard deviation, but percentually, in percentage, there is not such a high difference. When we make a scatter plot, we see that we don't see clear patterns, especially if they don't share variables. For instance, here it is USD Swiss franc versus Euro Japanese, and then we don't see any special pattern. The same here, that they don't share any variable, but if they share a variable, then sometimes we see some pattern. So for instance, here we have euro divided by dollar, this is dollar divided by Swiss franc, and there is a negative relationship that reflects the point that here the dollar is in the denominator while the dollar here is in the numerator. Okay, so we can look for the correlation matrix, and the correlation matrix, for instance, this we already saw that there is a kind of a strong relationship here that is negative, and this is reflected in this large negative correlation value. We can plot it. We can also see that this one is one of the most related ones. So this is euro Swiss franc, and this is euro Japanese, and the Japanese yen. So the euro here is in the numerator in both cases. So this is a really interesting relationship, because it is not something expected from this inversion from denominator to numerator. Okay, these are the mean values and the standard deviation that we know that they are used in the PCA analysis, because the covariance is x1 minus the mean of x1 times x2 minus the mean of x2, and then the correlation divides that by the standard deviation of 1, the standard deviation of the second. Then we will do the principal component analysis. We already saw this point that this block is normalizing the data, so it is standardizing the data, so the x minus the mean of x divided by the standard deviation of x, and that makes that the correlation matrix and the covariance matrix are the same. We do the PCA, we analyze the coefficients, so we see that the most important principal component is the large weights are almost all of them are large weights, and you see these two, this is also in the same range and this is also in the same range. So this PC1 is positively correlated to these two variables and negatively correlated to these other two variables. So this one negatively and negative. Yeah, this is also negative, but the value is not that high. Okay, so we can plot this visually, and we can also see this projection of the variables onto the PCA1, PCA2 space. And for instance, we saw that there is a strong relationship between USD Swiss franc and euro dollar. So let us look at this. So here we have the euro dollar and here the USD Swiss franc. So because of the projection, it seems that this is pointing inward, so it doesn't seem that the correlation is exactly 1, and that is actually what we saw from the scatter plot. And yeah, so here it is interesting in the sense that here we have the PCA, that there are some properties. We have some size components and some shape components, and then the distinction between the two is the combination of signs. So if all the signs are of the same sign, then it is a size component, it is a kind of weighted average, and here we see that all of them are shape components. So even within each one of the principal components, we see that we have a combination of positive and negative signs, except this one. This one is a shape component. The third one is a size. Sorry. So it is somehow an overall weight, and this overall weight is what makes all these axes point in one direction. So they all point into the negative side, onto the negative side, and then that means that PCA3 is a size component, while the other two, the PCA4 is a shape component. So it is opposing these three variables to these other two variables. Here, one of the most interesting analysis we can do is how many independent components do we have. So we saw that we had 4 currencies, so we should have only 4 independent components, and that is the case. We see that most of the information is in the first 2 components. The last 2, they are mostly noise. So the first 2, with only 2 components, we would be able to more or less explain most of the variability, actually around 90% of the variability, and that now we can project the 5 relationships onto this 2-dimensional space, and this would be the kind of plot that we would get. So somehow what all these currencies are doing is a kind of a random walk around this pattern, and then moving up and down along the pattern. And this would be very interesting to simplify the currency space and concentrate on this 2-dimensional space. This would be all.